we will now start working on the, like we talked before, we will talk about definitions, declarations, pass by value, all the 6 of them as we go. Here I have declared a structure with a tag name underscore person, right? And so I have separated the definition here. This is the definition from the real declaration. If this variable person is declared and allocated, right? Memory is allocated. And here we are defining a structure with a tag name underscore person, right? And see how I'm using the struct and tag name as a type to declare a variable person. So now we will go ahead and see how the size of is different here, right? Yeah, so if you want to do that, gcc struct.c gives you 36 here, right? This is 36, which is good because 32 plus 4 is 36. Now what if I change it to 30? So 30 plus 4 should be 34, but I got 36. Why is that? Because of optimization, it always puts the structural members at the word boundaries. All right. Somehow it took 30 bytes and padded 2 more bytes to that. Okay, these 2 bytes are padding. You won't see that. And then 4 bytes for the integer. So total is 30 plus 2, 32 plus 4. So even though you don't use these 2 bytes, so the total is 32, 36 bytes. Okay, so that is how the size of works. Now if you want to copy, so we are done with that. Okay, one program we are done. We'll go ahead and copy the struct to initialization or assign where member as assignment.c. So member, what I'm going to do now is say string copy person dot name. Let's keep it John. Copy John, and I'm going to age, keep his age somewhere around 30. Okay, now let me print him. How do we print it? Name equal %s, right? And age equal %d. How is that now works? Person dot name, person dot age. That should work, right? So we have assigning some values to the members, and we are printing them. So gcc member, oops, on some warning here. is incompatible implicit declaration of built-in function string copy. So what it is we did not include string copy strings. You see how I'm using the angle brackets, right? Okay. GCC will get you, it prints name equal to John, age equal to 30, the way we did it. So this is assignment and accessing, right? So that's how we do it. Okay, we're done definition, done declaration. We'll come back to value later. Let's assign one structure to another structure. All right, how is that? Okay, let's define a person called neighbor. All right, and then what we do here is neighbor equal person. You see that I just assigned to a assigned a structure simply using the assignment operator to another structure. Both are identical types. The identical type is struct underscore person. Then we want to double check, right? We want to double check neighbor name and neighbor's age, right? Okay, so I'm printing both. So let's see if it copies perfectly for us. You see that? It copied perfectly for us, right? So you can assign structures to one another, right? It simply copies it. And so we are done with assignment. Now we need to compare, right? We need to compare if they are same or not. So let's talk about instead of neighbor, friend, right? And I will, no, I can, I don't need that. I can compare here. I copied. Now I say compare two structures. We are assigning two structures, assigning a structure. Okay, and here we are comparing. How would you compare? If neighbor equal person, then you say printf the persons are identical, right? What happens here? So neighbor equal to neighbor. So let's see what it does. GCC member. By the way, it won't compile. Okay, I'm just telling you. Error: invalid operands to binary, because in structures you cannot compare to in a way they have purposely avoided doing that. There is no bottleneck, there is no limitation. The main reason is it's limiting the comparison of very large data structures will be very cumbersome, and this also leads to a lot of confusion, especially when you use pointers. So that's why they inhibited that from doing it. So you can't compare structures. So we need to go ahead and change it. So how would you compare then? If I want to compare, how would you compare two structures? The only way you could do is, so you cannot compare two structures. Okay. So what I'll do is I probably show you if 0. That means don't do that anymore. When I do end if 0, what it means is in the preprocessor itself, it will remove the whole thing within this, anything within these two markers, if 0 to end if. That means if it's false, don't do it. So it is false, don't do it, right? So it won't compare, it won't compile at all. Okay. If 0 won't compile the code. Okay. I'm leaving there for your reference. Now if I come here, how would I compare then? If neighbor dot name, can we compare like that? I'm sorry, not neighbor, person. Can I compare two strings using equal operator? Yes or no? You cannot, right? How would you compare? String compare, right? String compare, if both are same means equal 0, and right, and neighbor dot name dot age equal person age, right? Yeah. So if both age is same for the person and the neighbor, and the name is same, right, then you say the persons are identical, right? So you got that. You can also use else. So it will now include this code. Okay. It will not include this code. Okay. Okay. See, the persons are identical because we copied, and then we compared. See that? If you now if you want to turn on this code, okay, if 0, and you are doing what you are doing is you are eliminating this code and introducing this code within this hash if. Now if I compile this, now it won't compile. So that this is very useful in if you're developing a lot of products. Sometimes you don't want to include some codes in the preprocessor itself. So if you want to go back to this other code, you simply say 0. Okay. Okay. Persons are identical. So we are now done with assignment compare. We need to pass value to functions. How would you pass structures to functions, right? How would you do that? So let's go back. Let's copy this member to struct function. Let's see. So struct function. Okay. Here, what I would do is I don't want it. I'm going to declare a function. Say void copy. I'm going to copy here. Copy one structure to another structure. Struct. What is the data type? In this case, the data type we use is struct underscore person. I'm going to call it just a P, right? And I'm going to copy. So I'm going to move this copy guy. I'm going to move the neighbor within this here, and I'm going to, we're not going to do assignment. We'll move the code here. All right. And we don't need any of that. We'll remove all this code for now, okay? I'm going to remove all this code. We don't need any of this code. Okay. All I did here is I copied to neighbor. That's it. So we want to make sure that we copy it perfectly, right? In here. So it is neighbor. Okay. That's it. We don't need it here. So we are only printing in the function. Okay, got it? So we are passing structures, to a function. Okay, GCC struct function. See, there is no errors. Oh, we didn't call that function. We had to call that function copy person, right? We are calling the function, and the function we are doing. And see how I defined the type. Compile. It prints, right? We are printing this in the function, not anywhere else. Now what if I change something in the function? I want to change my neighbor age equal 70, right? Will it change my person's age in here? I'm going to print here. Person a name, person age, person. Okay, so this is person name, this is neighbor name. After I call the function is changing the value from 30 to 70 in its local variable, and let's see if it reflects in this person that we sent, right? If you see it, after we call the function changed the value of age to 70 in the neighbor's copy, but the person's age remains 30. So what it means is structures are passed by value, because that's how we did it.